The geometric mean is a middle term of a geometric progression, just like an arithmetic mean or average is a middle term of an arithmetic progression. To find the geometric mean, which is in this case 12, this number in the middle is our geometric mean. We could do it a few different ways. We could write an equation 12 times r goes from 12 to 108, and that would find the r, and from the r then we can use the r to calculate the middle term, which is then would be the geometric mean, the middle number of a geometric progression. That's one way to do it, so I'll just put that as 1. Okay. The other way you could do it, and this is a little bit quicker, is the middle number of an arithmetic sequence is the first plus the last divided by 2. In a geometric mean, we can say that if the middle number is x, we can say that the outside numbers, first and last, multiplied together, and instead of dividing, I root that, or I can say that that's squared, is going to give me that term. And then when I solve for x, so this is going to be 12 times 108 is going to be 1296, and the square root of 1296 is going to be plus minus 36. Okay, so when we square root both sides, so I multiply the two and I square root, I get the middle. Since it's a square root, I have to do plus minus. So the geometric mean, it could be either 36 or negative 36, depending on if r is positive 3 or negative 3. If I were to solve for r directly, I would solve this equation. 108 divided by 12 is equal to 9. So r squared equals 9. R is equal to plus minus 3, and plus minus 3 would then get me to the middle number of 36 or negative 36. Here we have an arithmetic sequence, and we want to solve for the value of x. Well, we could make an equality by doing this. We can say that t1 or t2 minus t1 is equal to the common difference. We could also say that t3 minus t2 is also equal to the common difference. By doing that, we end up with 5x minus 9, t2 minus t1, which is x plus 8, is equal to the common difference, which can also be expressed as t3 minus t2. And since they're both equal to common difference, they're equal to each other, I've now come up with an equation that allows me to solve this. Solve for x. 4x minus 17 is equal to negative 3x. 2 minus negative 9 is going to be plus 9. It's going to be plus 11. So now I have an equation with 1x. I can solve for x. 7x is equal to 28. I get x is equal to 4. Okay, so then I could also, once I figure out x, I can just check to see this is in fact arithmetic sequence. 4 plus 8 is 12. That's going to be 20 minus 9 is, so 20 minus 9 is 11. And 2x plus 1, or sorry, 2x plus 2, or 2 times 4 plus 2 is equal to 10. Yeah, the common difference is negative 1, so it goes down by 1 each time. This is a similar problem, but we want to find the x value when we know that this is a geometric sequence. We can do the same similar thing to what we did before, except in this case it's geometric, so we're going to divide. We know that if we divide consecutive numbers, we get r. If I divide these t3 and t2, I also get r. So I end up with this expression, 2x plus 1 over x minus 2 is equal to r, and it's same as 4x divided by 2x plus 1 is equal to r as well. So if you notice that if this is where I get that formula. This is going to be the middle squared times the first and the last. So I end up with 2x plus 1 squared is equal to 4x times x minus 2. I can then solve this equation by expanding out. The 4x squareds cancel out. I end up with 12x is equal to negative 1. Okay, just double checking my math here. The x value then works out to be negative 1 over 12. Ooh, that's a strange result, but we'll have to check that. Testing that, I do negative 1 over 12 minus 2. That gives me negative 25 over 12. Negative 12 over 1 over 2, or sorry, 1 over 12. Negative 12 over, that's going to give me negative 2 over 12, plus 12 over 12 is going to give me 10 over 12. Okay, and then the last one is going to be 4 over 12. So I'm just going to simplify this. So this is going to be negative 25. Sorry, that's going to be negative 4 over 12. Over 12. This simplifies to 5 over 6. And this simplifies to negative 1 over 3. So that's going to be divide by 2, divide by 2, divide by 5, divide by 5. Yeah, it looks like it's a geometric progression where the multiplier is negative 2.5, and that's going to, negative 5 over 2, yeah. And that would give me, it should be, I got that backwards, should be negative 2 over 5, and that will give me this progression. So this is in fact a geometric sequence which follows these terms here when I solve for x as negative 1 over 12.